Okay guys, on this video we're going to look at how to prove the sum of geometric series in a way that you all guys are going to understand what is going to happen here. So I found out that in a lot of papers, question papers, they ask you to prove this proof, and a lot of students, they ignore these easy marks that you have to take here. So on this video I'm going to break it down so that you can be able to understand how to prove this instead of cramming the information. So here they ask us to prove that this sum of geometric series is equal to all this kind of stuff. So here what is happening, we know by definition the sum is equals to all the terms, term 1, term 2, all the terms including the last term. You understand? The sum by definition is equals to all those kinds of the terms that is in the pattern including the last term. You understand? So we're going to prove this using this kind of stuff. So let's go. So now we're going to the sum, we're going to define all this kind of stuff, since we know that Tn is equals to what? Is equals to ARN minus 1. So when we want the term number 1, we're going to substitute 1 here and then we'll find the formula. So let me write it down here, all of this, and then I will continue with it. So here's all the terms. Now, T1 is going to be equals to what? Is going to be equal to A. If you don't understand, I demonstrate all these guys in a way that you're going to all understand. Now, T1 is going to be equals to A, and then T2 is going to be equals to AR, then T3 is going to be equals to AR squared. Now, and then dot, 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 and then we'll come to this. This dot, guys, it means like this these terms are continuing up until the last term. We can write T4, T5, T6, but we want to save space. We want to take the letters that are imported. Note that we want to take the letters that are imported here. So what will be Tn if we define it? Here, this is where it's getting a little bit trickier, because a lot of students, they don't understand, because when you check a lot of guidelines, you will find something like Tn is defined as something that is equals to ARN minus 2. And a lot of my students too, they are struggling to understand why does Tn minus 1 is equals to ARN minus 2. So let me try to break it down to you so that you can be able to understand why this is kind of stuff is equal to this. Remember, if you are having f of x, f of x that is equals to 2x minus 1, I'm just giving an example. So they say that look for equation of f of x minus 1. What will be f of x minus 1? You will simply do what? You will simply substitute this x minus 1 on this x, and then you're going to substitute this 1 minus 1, and then you do what? You say 2x minus 2 minus 1, you understand? And then you solve and you find that kind of equation. But what I want you to understand is how you find this kind of equation. You substitute where there is x, you substitute this x minus 1, you understand? So it's the same thing here. Tn, we know that Tn is equals to what? Is equals to ARN minus 1. And when we are looking for Tn minus 1, it's the same thing. We're going to substitute these things on the value of n, what we do here. So then we're going to substitute this, and then this is going to be n minus 1 minus 1. You understand that? And then Tn is going to be equals to what? To AR. If we minus this, we're going to get n minus 2. Hence here, you find it on your guideline or on your memorandum. They write something like ARN minus 2. And then this one, you know that this is going to be equals to AN minus 1. So remember, guys, this kind of information is not important enough, but it's important to start. We want to make two equations that when we subtract the second equation with the first one, which is this one, we're going to cancel all this kind of stuff and we'll be left with this. We want to be left with A and ARN. Do you understand that? We want to be left with this kind of stuff on the equation that we're going to create. So let me just write it down so that it can be able to make sense to you. We want to create a second equation. How are we going to create the second equation? We have to multiply this both sides by r. You understand? And then when we multiply by r here, we're going to get Sn, and then we multiply by r here, we're going to get, if we multiply all these terms, let me write it down so that it can be understandable. So look at this. We multiply all these things by r, and then already Allah we multiplied. So we have to like multiply it so that you can be able to see. So I will pause the video and I will multiply all this kind of stuff so that I can be able to save time. Okay, so now I multiply all these kind of terms that are here by r, and we're getting something like this. So here where everything is getting a little bit tricky for a lot of students. If you pay close attention, this is our first equation, and then this is our second equation. In most books, when you find the first equation, it will be like this, and then on the second equation, you will find something. Yeah, when you on the first equation, actually, you will find something like this one is not there, but this one is there, but this kind of term is not represented on the first equation. Let me show you what I mean. If you pay close attention here, we say that we want to create an equation that when we subtract it with the first equation, we're going to get a and arn. Do you understand that? So if you pay close attention on this kind of first on the second equation, if we subtract this with this, this AR is going to be cancelled with this, this AR2 is going to be cancelled with this, and then this ARN is going to be cancelled with this, and then we're going to be left with what? With this thing and this thing and this thing here. You understand? And also this. You understand? So in order for us, we know that we want to be left with this and this. So we have to eliminate what? We have to eliminate this AR3 because it's not going to be cancelled out with anything. And we also have to eliminate this ARN minus 2 because it's not going to be eliminated by anything there when we subtract. You understand that? And the reason why we don't eliminate A and ARN is because it's something that we need on this formula. Is it clear? So, okay, let me also try to rearrange this kind of equations, then I will continue the video. Okay, so here's the thing. So if you pay close attention here, our equation 1, look at it now. We eliminated what? We eliminated this term here. Why? It's because we don't need it. Why we don't need it? Because when we subtract this second equation that is here, it's not this AR minus 2 is not going to be eliminated with anything. You understand? So hence on some guideline, you will find that they write something like this, and then on the second one they write something like this, but you don't understand why this term is formed. This term is formed when we multiply R with it, and we get something like this. I hope now it's clear. And then look at the second equation also. We also eliminated this term here, which is AA3, AR exponent 3. We eliminate. Why we eliminate it? Because it's not going to be separated by anything when we subtract here. Because, and pay close attention, this dot, it means that the pattern continues. We can write A4, A5, up until all those kind of last term, but we want to save space and take the letters that we need at the moment. You understand? So that's why here we are going to be left with something like this. I hope this is clear to you guys. And then we're going to subtract this equation, the second equation. We're going to subtract the second equation with the first equation. So let me try to rearrange it, and then I will continue the video. Okay, here, before I continue to put minus here, okay, look at this. I take the second equation, which is Sn, and I subtract it with the first equation there. And then I also have to do the same thing on this second equation, which is this one. And I also have to subtract here. When you subtract, put a bracket so that you can be able to understand this kind of stuff. When we put the brackets and we put the first equation here, the first equation is going to be like this. This is the first equation. It's going to look something like this. And then we have to remove the bracket now. Okay, so now pay close attention. When we multiply all these things by negative 1, we're going to get negative of all these kind of terms. So here we're going to cancel out. If you see this one, AR is going to be cancelled with this because this minus this is going to be equal to 0. This is going to cancel this because this minus this is going to be equal to 0. And this is going to cancel this one, and we'll be left with these things here. That's what we're looking for. Sn is equals to Sn, which is equals to ARN minus A. I hope this is clear, guys. So what do we do here? We're going to take the common factor, which is Sn on the other side, and then we divide both sides by what? By R minus 1. Then this is going to cancel this, and then our answer is going to be equals to Sn is equals to A over A over, and this is our proof, guys. If you didn't understand this, guys, I beg you to please replay this video. I try my best to further demonstrate what is the misunderstanding to a lot of students. So if you find this video useful, you can subscribe to the channel and recommend this video to your friends. So thank you so much for watching. Have a good day.